We ripped out the synchronous endpoints, and now this research agent runs securely in the background for 10 minutes straight. You know that feeling. You build a complex AI agent and it works perfectly locally. Then you deploy it. The API request takes 3 minutes and your server drops the connection. Standard REST endpoints just cannot handle long-running agents. Today we are fixing that with a real worker queue. So here is the thing. Instead of making your API wait, FastAPI hands the job straight to Celery. It immediately returns a task ID. Redis sits right in the middle, acting as the message broker. Your OneGraph agent runs completely independently on a separate worker process. We will look at task polling later. Alright, the data flow is actually really straightforward. The front end simply pulls that specific task ID endpoint to monitor the agent's progress over time. When the heavy background job finishes, Redis caches the final result. Then the client can safely retrieve it. It will make more sense once you see it in the code. Let's get our environment ready. We need python.env to manage secrets and the official OpenAI SDK for our model calls. Run this install command to grab the packages along with FastAPI and Celery. Before we write any Python, we need our message broker running. We are using Docker to spin up a local Redis instance. It is way cleaner than installing it directly on Windows or Mac. Just map port 6379 and the broker is ready to accept connections. Next we create our .env file. And here we store our OpenAI API key. After that we create the worker.py. And now we start working on our background worker. We pull in os and .env to handle config loading. Then we bring in the Celery framework and the official OpenAI client wrapper. So here is where we boot our integrations. We call load.env right away to inject our secret key into the environment variables. Then we instantiate the OpenAI client wrapper. We also keep our Celery application configuration pointed directly at that local Docker container that we started earlier. The backend parameter ensures Celery saves our final response text right inside Redis. If you skip this part, your API can never retrieve the data. Now we implement the actual network call inside our background task. We use GPT-4o Mini here because it is fast and cost effective. Notice that we map the incoming task prompt argument straight into the user message payload. This network operation might take a couple of seconds to resolve. Because it runs out of process inside Celery, it will not block our main application loop. Once the model responds, we return a structured dictionary containing the exact completion text. Next we create our main.py file. The imports stay clean and minimal here. We bring in FastAPI to build our web endpoints, async result to safely check status, and our configured worker handles. Let's set up the core application instance and build our task execution route. Instead of waiting for OpenAI during the request cycle, we call our function using the delay method. This pushes the task parameters straight to the Redis queue and immediately hands back a tracking ID. The HTTP connection closes instantly. This design pattern protects your endpoints from closing due to gateway timeouts. So the client has a task ID. Now they need a way to check on it. This is that polling mechanism we discussed. The endpoint takes the ID and queries Celery for the current state. If the agent is still working, it returns a pending status. If it is done, it grabs the stored result from Redis. This lets your frontend show a loading state without holding an HTTP connection open for 10 minutes. Now let's test the whole flow. In the first terminal, we start the Celery worker so it begins listening for jobs. And after that, in second terminal, we spin up the FastAPI server. And now let's trigger the async pipeline from a new terminal. Let's send a post request to start the agent. We have passed a clear question about quantum computing. As you can see, we get a task ID back instantly because the main API thread doesn't wait for the worker. Now we grab the actual output. Take the task ID from the previous step and send a GET request to the polling endpoint. Since a few seconds have passed, the background worker has finished the job. Notice that the response now contains the complete success payload along with our research data. We have successfully executed a long-running agent without blocking the server a single time. So now you have got a robust asynchronous architecture running your AI agents. Your API endpoints will not time out anymore. OneGraph can take 10 full minutes to finish without crashing the server. You have got a Celery worker managing the heavy processing in the background, and Redis keeps track of the state automatically. Next step, try deploying this exact setup to a staging environment, and push a massive prompt through it. Watch how your frontend stays perfectly responsive while the agent does the deep thinking. And if you want more practical infrastructure builds like this, hit subscribe. I'll catch you in the next one.